Greetings and welcome to module 2 of TALE. Many of you or most of you would have participated in the module 1 of TALE. This is module 2, which is in continuation of that. And as you know, TALE is a course that facilitates the teachers in the context of the NBA accreditation and the what we call as the good characteristics of engineer. It facilitates the teachers to plan their courses and conduct their courses. So, TALE the module 2, the unit 1 is we are going to look at engineering programs. What are they? NBA accreditation and engineering courses. As engineering teachers, all of you are familiar with this, but we will try to spend some time in looking at this in one particular sequence, because some of the terminology, if not all the terminology, is somewhat recent, and to that extent different faculty members may use these terms to mean different things. So, the first unit tries to look at engineering programs, NBA accreditation, and look at what are engineering courses. So, what does TALE do? This course, entire TALE with all the 4 modules, aims at enabling the teachers in engineering programs to facilitate their students to become good engineers at the time of graduation. So, it is a second order input kind of thing. The course enables the teachers who in turn can facilitate their students to become good engineers. The course is offered as 4 modules, which we have mentioned earlier. One is looking at learning outcomes, the second one is course design, third one is instruction, and fourth module is accreditation. And now, as per the NPTEL format, each module constitutes 1 credit. Each module is also offered as 20 units of about half-hour video lectures. Each unit will have a set of exercises, and each week will have an assignment or a quiz. Of course, in the end all of you will be writing an examination which should lead to the award of a grade and certificate. Now, let us look at the structure of TALE, which we have presented in module 1. The same structure we are repeating here. TALE has 4 modules, as we mentioned. Module 1 is related to learning outcomes, and that is where we also otherwise called it outcome based education, and we will say what exactly we reviewed in that we will presently see. Module 2 is related to course design. That is what every teacher will have to do with their course, and if I design my course well, maybe my students will learn better. And this course design is presented in the framework of ADDIE, which we will elaborate in later units of this module 2. Module 3 will look at mainly instruction. How should you plan your instruction? Or planning instruction means planning and sequencing learning experiences of the students. We will talk about the related theory and how it can be presented. Module 4 is strictly accreditation. These days each program, engineering program, will not required to, but most of the engineering programs go for NBA accreditation, and also every engineering college or every institute offering engineering programs goes for NAC accreditation. So, we will in the fourth module we will look at the accreditation processes. Okay. And now in TAIL module 1, if you recall, and we are also assuming all the terminology, all the exercises of what we have done in TAIL module 1 are prerequisites to TAIL module 2. So, we are not going to repeat much of what has been addressed in TAIL module 1. Okay, in module 1 we understood the nature of outcome based education, objectives and outcomes of an undergraduate program in engineering as required by National Board of Accreditation, because our framework is always the NBA accreditation framework or the guidelines provided by or a framework provided by AICTE and so on. And we also understood the Anderson-Bloom-Vincenti taxonomy and the three domains of learning, namely cognitive, affective and psychomotor domains of learning. We understood the features of the three domains, and particularly in the cognitive domain the Anderson-Bloom-Vincenti taxonomy. And we also wrote outcomes of a course in an engineering program that address a subset of program outcomes and program specific outcomes. So, at the end of module 1 we not only wrote outcomes of a program, outcomes of a course and how to write that, as well as how to measure the attainment of these outcomes. We have looked at both of them in the module 1. Now, the remaining outcomes of this TAIL, that is at the end of module 2, 3 and 4 of TAIL, the students who are mostly practicing and aspiring teachers should be able to design a course in an engineering program in the instructional design framework of ADDIE. So, we will be elaborating in the module 2 about the framework of ADDIE, and also design assessment that is in good alignment with course outcomes. So, in the module 2 we will be looking at what we are calling as ADDIE. It has 5 phases. ADDIE refers to analysis, design, development, implement and evaluate. We will be looking at how to perform activities in all the 5 phases of ADDIE, and particularly we expect the participants who are in the TAIL module 2 should be able to design assessment that is in good alignment with course outcomes. That is the module 2 outcomes. Module 3, design instruction following Merrill's principles for attaining the course outcomes and competencies, ensuring good alignment between course outcomes, assessment and instruction. That is module 3. Module 4, prepare for NBA accreditation at the department level, and also prepare for NAC accreditation at the institution level. That is module 4. And this course, as we mentioned earlier, will be useful to working teachers in engineering colleges, aspiring teachers, graduate students who wish to make careers in education technology, and also companies offering education technologies and training programs to corporates, educational institutes, teachers and students. Now these days there are any number of companies that are coming up in India who are trying to design and conduct programs for the corporates as well as for the educational institutes. Now we need to be clear about a few terms. People use other words for this, so we will try to pin down specifically certain words. Let us see what engineering programs are. Engineering program is a 4-year teaching and learning activity that can qualify 12th standard graduates to the award of engineering degrees. So when you say a program, it always leads to a kind of a formal degree. That is what we call a program in the present day context. And engineering programs are required to impart, this we have mentioned already in module 1, impart knowledge, skills and attitudes, and to facilitate the graduates of 12th standard to acquire the characteristics of a good engineer. Who defines the characteristics of a good engineer? They are identified by National Board of Accreditation. They use the word program outcomes. That means the program outcomes represent the characteristics of a good engineer as understood today. This may keep changing slightly from time to time. So it is not as if you write the program outcomes once and they are permanent. As the technology changes, the role of engineers change, so the nature of program outcomes also will have to change with time. Now engineering programs in India, this is what every teacher needs to be very clear. They need to be designed and conducted as per guidelines given by AICTE. AICTE is All India Council for Technical Education. And what are the guidelines they give here? They are related to the program title. That means what title you can use to your program, BTech in computer science or BTech computer science and engineering. So whichever degree that you offer, the title will have to be generally accepted by AICTE. Of course, AICTE also from time to time will keep modifying the list of program titles. Then the guidelines are given with respect to outcome based education, duration of the program, the semester system, the number of credits for which the program has to be designed, what we call curricular components, grading and physical infrastructure. So these are the guidelines that AICTE provides. Unless you follow that, AICTE will not permit you to conduct and award or qualify your students for the award of engineering degrees. In addition to this, guidelines of state governments, they are with regard to reservations, fee structure and admissions. There may be many more, but these are the main guidelines that the state government gives. And most of the colleges in India are affiliated to some university, and it is a university that awards the degrees, not the college, except in a few cases where they are private universities or which are established by central government as well, either state or central universities. And guidelines of the affiliating university with respect to again admissions, curriculum, examinations, evaluations and declaration of results. With respect to all of them, the affiliating university will have guidelines and some constraints. So what happens, engineering programs will have to be conducted, designed and conducted under the guidelines given by AICTE and state government and the affiliating university. This is what every teacher obviously will know, but has to be understand in the corresponding framework. And once again, though it is not compulsory to get National Board of Accreditation what do you call NBA accreditation for the program, but majority, you can say 95% of the programs would want to go for NBA accreditation. So if you take that as one of the requirement, and NBA talks about vision and mission of the institute, that means the institute has to write a vision and mission. It does not say what that vision and mission should be, but they have to write vision and mission of the institute, vision and mission of the department, program educational objectives, program outcomes, program specific outcomes, course outcomes, and how do you attain the COs, POs and PSOs, and generally closing the quality loop and ensuring that you are trying to improve continuously. So these are all the aspects of NBA accreditation as far as designing and conducting a course. This is what one should be familiar with. And all this, other than vision mission, the rest of the things we have addressed, at least in the terminology, what they are, how they are related, all those issues we have already addressed in module 1. And engineering programs, if you want to understand prior to the introduction of OBE, that is prior to 2015 practically, while informally there were some understanding, but no formal framework was identified by any agency or an institute for designing an engineering program. For example, if you look at any document given by any institution offering engineering programs, there is no framework document saying that what are the objectives of the program, what are the program outcomes, or at least any equivalent word for that. Nothing like that was written. So more or less the so called framework is was either informal or unstated at least. So now we are required to state everything on a piece of paper. So there is clarity about the framework in which a program and a course is designed and offered. There were no criteria identified at the program or course level that were required to be met. There is nothing. This led to a position that faculty member in an autonomous institution has total freedom with regard to design and conduct of a course. One is not answerable to anything. I just pick a course, design my syllabus and offer it the way I consider the best, either from the subject perspective or whatever goals that I have in mind. Even the goals are not particularly stated. So this right to total autonomy and no need for a framework still continue with majority of the faculty members. That is the reason why, having got used to operating with no framework, the many faculty members may feel a little constrained with regard to providing any framework. We will presently see that aspect. Now let us look at how courses are. First, courses are classified into these categories. The curricular components include basic sciences. How many courses, what courses, that depends on a given program. That is not stated by NBA or AICTE. But there is a basic science component. Basic sciences normally constitute physics, chemistry, mathematics, biology, such things. Humanities and social sciences, this will include language and including management and any other social science subject. Then you have engineering sciences, professional core, professional electives, open electives and a project. These are what we call broadly curricular components. So whenever somebody designs a curriculum, first thing that one does is the whatever credits of the entire program are distributed under these curricular components. How many credits of the total program are allocated to basic sciences. And of course, some courses one may find it difficult to, there will be some courses in the curriculum one may find it difficult to put under one of these categories. But any classification, you cannot create too many categories. So, we have to tolerate, sometimes we may say one particular course, should it come under engineering science or basic science, or should it be shifted to core and so on. These issues will always be there, but it does not matter. These are officially the categories that are identified, the 7 categories, and all courses will have to be put under one of these 7 categories. And now the program structure, at least now we can say, as far as the AICT is concerned, a BE program will have a credit load of about 160 credits. That means it could be 160 plus or minus a few. So, many people still, though till now there are large number of programs which are operating even up to 260 credits on paper, though their credit definition will keep changing, but the majority of the programs in India are operating anywhere up to 200 credits, and in the recent past they are coming back to around 160. Many of the programs have come back to 160 plus or minus 5, or sometimes 160 minus 5 to 160 plus 10 kind of thing. They are trying to come within that. And these credits, whatever number that you choose, are distributed over the curricular components, keeping the POs identified by NBA, PSOs identified by the Board of Studies, and the requirements of the university, AICTE and UGC. These are that many constraints that you have. For example, UGC says you have to have a course on ecology or environment, whatever name that you want. Sometimes a university may say every student will have to go through one course in local language, and sometimes a university may also constrain there should be a course specifically identified on professional ethics. So on, to that extent there are requirements that come from any of these agencies, and we have talked about POs and PSOs. POs are identified by NBA and PSOs are identified by the Board of Studies associated with the program. Okay. So, and the courses identified by all, generally the final selection of the courses will be done by Board of Studies. They have to put the courses under these 7 categories that we talked about. And courses can be offered as 3:0:0 or 3:1:0, 3:0:1 and so on. There can be, for example, a project can carry, we can name it as 0:0:12 or 8, whatever number you have for the project. So you have courses. The courses earlier were characterized by the marks like 100 marks, 150 marks and so on. Here they are characterized by the number of credits and the grade that a student gets. Okay. Because now under the CBCS scheme, the student should have access to a wide range of courses from which he can choose, and we call them as electives. And another aspect that you need to keep in mind, the number of teaching weeks. Mind you, we are calling teaching weeks, not working weeks. Normally 90 working days is the norm of most of the semesters, but we won't be teaching all the 90 days. We are conducting internal tests, there are some preparatory holidays, then you have final examination and so on. So keep taking all that into account, the number of teaching weeks in a semester comes around to 14 to 15. Why is this important? The content of the course that can be addressed satisfactorily by all students should be selected keeping this number in mind. If I increase the content indefinitely, because as a teacher I consider all that should be learned, but I will not be able to do a proper justice during the 14 to 15 weeks. So that should be kept in mind, the number of weeks available for classroom interactions to 14 or 15, and the content will have to be accordingly adjusted. Credit and syllabus. One credit is this, we have explained in the module 1. Once again, one credit is one classroom session per week over a semester, 1 hour of tutorial per week over a semester, or 2 hours of laboratory work per week over a semester, and this will have to be strictly adhered to. This is right from UGC level, at AICT level, these are all applicable. No institution or no college should deviate from this definition of the credit. The syllabus of the course, as we mentioned, needs to be identified keeping the number of credits. Obviously some courses are 2:0:0, or some courses are 3:1:0. So depending on the number of credits and context here will refer to quality of students, infrastructure, POs addressed, etc., and nature of the subject in consideration. If the subject is highly mathematical and also very difficult concepts are involved, or very complex procedures are involved in the course, then obviously the content will have to be accordingly adjusted, not because the subject requires that. So the content should be decided by, or the syllabus of the course needs to be decided by these considerations. Broadly we need to divide the courses into two categories in another way based on the knowledge categories. For example, courses in humanities, social sciences, basic sciences. Courses in humanities, social sciences, basic sciences and engineering sciences deal with the 4 general categories of knowledge, namely factual, conceptual, procedural and metacognitive. Whereas courses belonging to professional core professional electives deal with the 4 general categories of knowledge and the 4 Vincenti categories of engineering knowledge, including fundamental design principles, criteria and specifications, practical constraints and design instrumentalities. When you come to open electives, the way open elective designed can belong to the first category or to the engineering category. That is the choice of the course designer. And this is these set of principles that we have been saying often in module 1 as well. Students learn well when they are clear about what they should be able to do at the end of a course, and these are written as course outcomes, and assessment is in alignment with what they are expected to do, and instructional activities are designed and conducted to facilitate them to acquire what they are expected to achieve. These are the principles of any good course. In unit 2 of this module, we present the role of course design in facilitating good learning. That will be the purpose of the course design. Thank you very much for your attention.